Hi, in this video I will explain Kirchhoff's current law using the proteus software. So first we have to draw the simple series parallel circuit in order to explain Kirchhoff's current law. First, kindly remember what is mean by Kirchhoff's current law. So in Kirchhoff's current law, in a circuit at any junction, the sum of incoming currents equal to sum of outgoing current. I repeat again, in a junction in any circuit, at a junction in any circuit, the sum of incoming current equal to the sum of outgoing current. So this is a Kirchhoff's current law. To prove this statement, I start drawing the simple series parallel connection here. So for that I make a 5 resistor. Let us consider resistor R1 and R2 is a input resistance. Just we assume that R3, R4, R5 is the output resistance. This R3, R4, R5 all three resistors are outgoing resistance. R1 and R2 is the incoming resistance at the junction. I am going to make the junction at this point. So here I am using the two separate source, so two separate DC source to give the supply to R1 and R2 resistor. So I want to measure current in each branch, so I require the DC ammeter. I collect the DC ammeter from instrument library. So I place the 2 ammeter in the input side. I place the 3 ammeters in the output side. I need one common ground also. I make a one ground here. So now I have to connect all the connection. So this is the first source I connected with 1 ammeter and resistance 1. Likewise, this is the second source connected with the second input ammeter and connected to the R2 resistance. These connections are series connection. Now I connect R1 and R2 like this. Okay. So actually this is a junction. This is the junction. At this junction only we are going to test the Kirchhoff's current law. So this is the junction. At this junction R1, R2 currents are incoming current. This R3, R4, R5 currents are outgoing current. So just remember, the Kirchhoff's current law states that the sum of incoming current equal to the sum of outgoing current. So R3, R4, R5 are 3 different parallel arms. This parallel combination connected with the R1, R2 parallel combination. R1, R2 also parallel combination. These two parallels are connected in series at this junction. This is the junction. At this junction we are applying the Kirchhoff's current law. So we have to make the ground connection. So before making this connection, I connect this with the ground. Then I can connect to negative terminal of the cell with the ground. So almost all connections are over. Now I have to adjust resistance value. I make simply the 2 ohm resistor for R3, 4 ohm resistor for any value we can fix. I fix like this. 8 ohm for R5. For R1 I make 5 ohm. For for R2 I make 10 ohm. Say battery 1 I make 5 volt. Similarly battery 2 also I make 5 volt. So almost we set all the values. Now we have to verify the Kirchhoff's current law. So what is the Kirchhoff's current law? At this junction, actually this is the junction. In this junction 5 parallel arms are connected together, R1, R2, R3, R4, R5. All these 5 arms are connected at this junction. Okay, so now we have to run. Just pause the thing. So this is I1 current, this is I2 current. These two are the incoming currents. If you are adding these two equal to sum of all these outgoing current, these two are the incoming currents. The sum of this incoming current equal to the sum of the outgoing current. Now we have to check. We need one calculator. Better we take one calculator. See, I will take one more calculator in order to show distinguish result. I take one more calculator. So I keep like this. So first I am going to add this to incoming current. So 0.74 plus 0.37 equal to 1.11. Almost the same current will be the sum of outgoing currents. 0.64 plus 0.32 plus 0.16. See now almost same. 1.11 here, the 1.12, little bit only change. Almost the same value we can get. Okay, so this is the Kirchhoff's current law. So at this junction, the sum of the incoming currents equal to the sum of the outgoing current. Almost equal answer we can get. So this point not one, little bit only change. That depends upon the resistance tolerance value. Maybe almost the value is equal. Otherwise some fractions, while we are doing some fraction, small deviations may possible there. So almost the answer is same, 1.1, 1.1. Okay, now the Kirchhoff's current law is proved. Thanks for watching.